everyone, I am Joshna and my teammates are Anusha and Namrata. We are team group by us. We are building an end-to-end analytics pipeline on healthcare analytics using Databricks Lakehouse. In this project, we are working as data engineers for a healthcare client. Our client is a hospital group that generates a huge amount of data every day, including appointments, diagnostics, billing, and doctor information. However, all this data is stored in different systems, which makes it difficult to use effectively. Because of this, they are facing a major challenge, which is they have data but they don't have clear insights. For example, they are unable to understand why patients miss appointments, which departments generate more revenue, and how efficiently doctors are being utilized. This lack of visibility affects both operational efficiency and patient care. So, they approached us to solve this problem. Our goal in this project is to take the fragmented data, bring it together, and convert it into meaningful insights that can support better decision making. From a doctor's perspective, this helps in better scheduling and reduces overload imbalance. From a hospital owner's perspective, it provides a clear understanding of revenue, performance across branches, and helps in making strategic decisions like where to open new branches and where the departments have a highest revenue and which departments to improve and how to optimize resources. So, this project is not just about handling the data, it is about transforming disconnected healthcare data into actionable insights that improve efficiency and support better healthcare. Our project has 5 core tables, which are appointments, doctors, departments, billing, and diagnostics. It has the column names as patient visits, time, status tracking, provider details, specialties, schedules, revenue payments, insurance claims like this. All this data is combined together as one pipeline, and we take the data and make clear insights.
Billing, diagnosis, and doctor records and departments. The main problem is that the data is highly fragmented and unstructured, so it often contains missing values, duplicate records, and inconsistent records and inconsistent formats. Because of this, it becomes very difficult for organizations to generate reliable insights or make decisions. So in our project, we designed a structured data pipeline that gradually improves the quality of data step by step. Initially, we collect and store the data exactly as it comes from different systems. At this stage, we do not modify it that much. So that the idea is to preserve the original data in its raw form so that we always have a reliable source of truth. This also helps in auditing and debugging if anything goes wrong later. After that, we process the data to improve its quality. This is where most of the work happens. We remove duplicate records, handle missing values and the standardized formats, and we also combine data from different sources. For example, connecting patient appointments with the doctor details and billing informations. This creates a more structured and meaningful dataset that can actually be used for data analysis. Once the data is clean and well organized, we transform it into a format that is easy for business users to understand. Here we create important metrics and summarizes. For example, we calculate a no-show rates, analyze revenue across departments, and measure doctor utilizations. These insights help stakeholders understand what is happening in the system and support better decision making. So overall, what we are doing is taking raw fragmented healthcare data and progressively refine it into a clean, reliable, and business-ready information. This approach ensures better data quality, improve performance, and make the system scalable for real-time analysis. So I'm going to show you the code for bronze and silver gold layer. So in this project, how we build a scalable data pipeline using modern data engineering practice. First, the bronze layer. This is the bronze layer. We just import the raw tables like appointments, doctors, and departments, and billings and diagnosis. In bronze layer, we just import the tables and it look like say raw tables. After silver, this is the silver table. Like Actually, in silver table we rename the columns and we convert the type and we handle the null values and also we fix invalid ages or negative values, and also we fix the invalid gender values and convert no show dates, and also we remove the duplicates, and after we joins the tables like this, and after we in goal just in goal table we can fix and transfer into a perfect format like this.
Hi, I'm Anusha. So far, my friends have explained what is our project and what has we done to get the raw tables to a perfect table which has all the metrics and all. So, up to I'll give an overview of that. So, we have chosen healthcare data set. In that, we have multiple tables like appointments, patients, buildings, and all. So, we have joined that table using the pipelines in Databricks. So, uh, for that, we have used Medallion architecture. So, we used bronze and silver layers to clean the data and remove the nulls and all. And then we have loaded the tables with the joiners. So, in gold layer, we'll be doing analytics, right? So, that is what I am going to explain right now. So, the key insights that we have got through this analytics is in this slide. So, the best APIs I've kept here. So, I'll explain one of each of them but now. So first, the best one is a no-show rate by waiting time. So what is no-show rate? No-show rate means the patient has visited the hospital or not is called no-show rate, and wait time is the gap between the scheduled day to the appointment day. So if appointments scheduled on the same day, maximum people are attending, and 8% of the people are not showing up in the hospital. And if the short wait period is there, then 39% people are going back. And if there is a long wait period, 50% of the people are going back. So this helps the healthcare centers to improve their scheduling types, and they can manage this, and they can increase the revenue by increasing the no-show rate. And so this is how they can use this analytics, and additional findings like revenue by department is also generated here in analytics. So each department will be there like cardiology, ENT, and these kind of departments. What the revenue is being generated by each department is also calculated. So to segregate which department is having most, and we can focus on that department mainly and improve the performance of other departments also by choosing what going wrong with that department. So, and neighborhood demand is also one of the key factor. Like neighborhood means the city or location of that healthcare center, which also helps to identify where we need to open the new branches and where we need to promote the old branches itself. So that helps us. And doctor utilization is also another thing where we can observe which doctor is being getting more appointments, and we can improve the doctors in our department like that. So that is how the analytics helps. And the next, the achievements and challenges and the future enhancements of our project is being discussed in this slide. The achievements are we have built a scalable pipeline which has processed millions of records. Like we have 1,10,000 test records in our dataset. So, and the robust cleaning and transformation of framework using the Medallion architecture, and then real-time visibility of and then into operational KPIs. So we have generated KPIs with that. So the challenges we have faced is we have worked with the pipeline for the first time in database, and that went big challenges. So then we have adapted to that later. So the future enhancements can be up to now we have the work with the static of our data set. We can connect to the Azure data lake storage where we'll be getting real time data, and daily data we'll be getting, and then we can use that data to do analytics. And the autoloader can also be used, so we can do merge operation here. And then real time analytics also can be done like say whenever the patient data is entered, we can immediately process that into our analytics, and then alerting system whenever there is a threshold points or it reaches a threshold point, we can just trigger the management to take the alert and manage the system efficiently and all. So this is what our project and I'll show you the dashboard of our project. So this is the dashboard, the neighborhood versus number of appointments and all, and the no-show rate versus lead time, and revenue versus department name. We can see the analytics and clearly get an assumption of where we are lagging in, and the company can improve their performance based on that. So here we have appointment month to total number of appointments. So in this data set, we have only a year data. In that too, we have 3 months of data. So on that, we have made an analytics. So this is how our project helps healthcare centers to improve their business and revenue and all. So thank you.